All right, let's dive straight into this explainer because we are witnessing a massive shift happening in the tech world right now. For years, everybody has been absolutely obsessed with building smarter AI models, competing purely on parameter size and benchmark scores. But we're hitting a ceiling. The base capabilities are basically converging. Now, the real frontier? It's not just the AI model anymore. It's the system that the model actually lives inside. Today, we're unpacking a massive new release that literally changes how AI agents are built from the ground up. To understand why this is such a game changer, think of an AI model as just a brain. A super genius brain, sure, but a brain just sitting in a jar. It can think, but it can't actually do anything on its own. It can't open a file, it doesn't remember yesterday's conversation, and it definitely cannot use external tools. The harness, on the other hand, is the body. The harness gives it hands, memory, a workspace, and the rules to interact with the real world. So when we talk about an AI agent, we're really talking about the model plus its harness. And whoever builds the best body is going to totally dictate what the AI can actually accomplish out in the wild.
Which brings us to our first major roadblock. Section 1. The fatal plugin problem.
Look, the fatal flaw with current AI bodies is that they are just incredibly rigid. If an AI tries to add a new tool on the fly, it usually demands a full system restart, which completely wipes its memory. Get this number, 87. That represents 87 out of the top 100 VS Code extensions. To just uninstall them, you have to completely restart the extension host for the changes to even take effect. It's a fundamental limitation of modern plugin architecture. You plug it in, but you can't cleanly pull it out without ripping the whole system down and booting it back up. For an AI, having to pull the plug to change a tool mid-task, yeah, that's an absolute disaster.
And this rigidity, it drastically affects both performance and cost. Recent tests by Composio took the exact same DeepSeek model and ran it through different harnesses to complete multi-step tasks. The results were honestly staggering. Trapped in the Pi agent harness, it succeeded 20 times. In Claude Code, 16 times. In OpenCode, only 14 times. And the cost to complete a single task swung wildly from 19 cents all the way down to just 4 cents. Think about that. It's the exact same brain, but entirely different results. The harness literally dictates everything.
So how do we fix this massive bottleneck? Enter Section 2, Cortis, the Lego baseboard.
Researchers from DeepSeek and Peking University just published an 88-page paper outlining a revolutionary framework called Cortis. You can think of it as the ultimate Lego baseboard for AI. Absolutely everything, from memory to tools to the core agent loop, is a swappable plugin. Now, it's powered by a secret sauce called Spatiotemporal Composability. I know, that sounds like an intimidating math concept straight out of Star Trek. But actually, scratch that. In plain English, it's just a programming paradigm that allows plugins to be dynamically loaded, unloaded, and rewired in both time and space without ever crashing the host system. It is the holy grail of plug-and-play architecture.
So let's look under the hood at Section 3, Mastering Time and Space to Create Perfectly Stable AI Environments.
To solve the time problem, they use something they call revertible effects. Think of this exactly like stacking dinner plates at a buffet. Every time a plugin makes a change to the system, Cortis records an explicit undo function, basically placing a new plate on the stack. Then, when you need to unload that tool, the system just runs the undo chain in reverse. It takes the plates off one by one. The system state is perfectly, cleanly restored to exactly how it was before the plugin loaded. Zero garbage state left behind. None. Okay, and to solve the space problem, they use reactive co-effects. This deals with dependencies. Say a chat plugin needs a database to run, but the database isn't installed yet. Well, the chat plugin simply goes to sleep. It just stays inactive on the Lego board. But the very second that database plugin gets snapped into place, the chat plugin wakes up and auto-wires itself. Like magic. If the database is removed later, the chat plugin safely goes right back to sleep. There is no manual integration code needed, totally avoiding those crash-inducing missing dependency errors we developers see all the time. All right, let's get into the practical stuff. Section 4, Inside the DeepSeek Harness. All that complex math actually powers a tangible, real-world product, the newly released DeepSeek Harness, and they launched it entirely free under an open-source MIT license. So what does it actually do? Well, it comes with 4 distinct running modes. You've got standard mode for your everyday multi-agent tasks. Minimal mode strips everything back to just shell and files, which is perfect for benchmarking raw capability. PTC, or code mode, lets the AI execute complex TypeScript code on the fly, but the real mind-bender here is creative mode.
This is highly experimental, but it allows the AI agent to actively modify its own Cortis plugins directly in memory while it runs. It can literally alter its own body in real time. And the engineering team behind this, led by a former Jane Street veteran with some serious algorithm chops by the way, made it incredibly easy to adopt. You don't need a PhD to run it. With just one single terminal command, it launches a slick web interface right on your local machine. It features an append-only logging system, meaning you have perfect audit trails of exactly what the AI did. It even reads existing instruction files from your other agents, like your Claude.md files, so you can drop it into your current workflow instantly. Plus, you get strict sandboxing and native support for open standards like MCP right out of the box. Because it was built to plug so seamlessly into our existing world, the community response was absolutely explosive. The team was only formed in May of 2026, they did their MIT open source launch on August 13th, and within 24 hours, the project skyrocketed past 60,000 GitHub stars. Then, it quickly blew past 130,000 stars as developers absolutely rushed to replace their rigid, closed-off toolsets with this flexible, open alternative.
Which leads us to our final point, Section 5, the self-evolving future. The absolutely crucial takeaway here is that DeepSeek Harness isn't just another toolkit or a fun wrapper, it is the prerequisite infrastructure for a self-evolving AI future, an AI that can write a brand new tool for itself, install it, test it, and smoothly uninstall it if it fails, all without losing its memory or crashing its environment. And if you're sitting there wondering, is this just lab theory? No way. We know this crazy level of dynamic plug-and-play works because the core Cortis logic has already been quietly running in production for 4 whole years. Yep, it was the backbone of a highly successful open-source chatbot framework called Koishi, managing an ecosystem of over 4,000 independently developed plugins without ever collapsing into dependency hell. The math is fully battle-tested. So, as the base intelligence of these AI models starts to level out and converge, the true winner in the AI race is going to be whoever builds the best, most adaptable body for the brain. DeepSeek just handed a massive MIT-licensed gift to the open-source community, empowering anyone to build and swap the engine, the wheels, and the steering wheel of their AI agents. Which leaves us with one massive question about the future of software development to leave you with today. In the long run, will these open, modular, self-evolving agent ecosystems beat out the highly polished, closed-source vertical integration we're seeing from the major labs? The race for the ultimate AI body has officially begun. Thanks for joining me on this explainer, and I'll catch you in the next one.